Welcome! Today, we're going to dive into a bit of hidden science that you actually use every single day, probably without even realizing it. We're talking about the science of separation.
So let's just jump right in with a question. Have you ever done a full-on scientific experiment right in your own kitchen? I'm willing to bet the answer is yes, and you probably do it all the time.
Just think about it. You're about to dig into a delicious meal, but you spot something you're not a fan of. So you carefully pick out those little green chilies from your poha before you take a bite.
Or what about your morning cup of tea? How do you get it perfectly smooth? You pour it through a strainer, right? To catch all those little stray leaves? Even making butter from curd is an act of separation. All of these things are fundamental processes we use constantly, from our own kitchens to gigantic industrial plants. We are, in a way, always unmixing our world. So, this all leads to a really important question that a character named Piheli in our source material brings up. Why do we even need to separate substances in the first place? Why bother? And the answer really boils down to two main things. First, we want to get rid of stuff we don't want, like finding little stones in your rice. But second, sometimes we separate things to isolate different components that are both useful, like when you churn curd to get butter and buttermilk. Okay, so the big question is, how do we do it? Let's build ourselves a little separation toolkit, and we'll start with some of the most basic, common sense methods out there. The very first tool in our kit is one we've all used. Handpicking. It's just perfect when the things you want to remove are a different color or size, and they're big enough to just, pick out by hand. Think about pulling a tiny stone out of a pile of lentils. Simple. But what if you've got thousands of tiny little grains all attached to huge stalks? There's no way you're going to handpick that. This is where farmers use a much more, shall we say, forceful method: threshing. They basically beat the stalks to shake all those valuable grain seeds loose. Now, this next tool in our kit is, I think, really cool. It's called winnowing, and it's this incredibly clever method that actually uses the power of the wind to do all the hard work of sorting for us. It's a really brilliant process. A farmer just stands up on a platform and lets the mixture of grain and husk fall to the ground. The wind catches the lighter, useless husk and blows it away, while the heavier, valuable grain falls straight down into a nice, neat pile. So simple, but so incredibly effective. Our next tool, sieving, works on a completely different idea. It's all about separating things based purely on their size. You use a mesh, or a sieve, that lets all the fine particles fall through while catching anything that's just too big to fit. And you see this method absolutely everywhere. It's what you do when you sift flour to get it super fine for baking, and it's what they do on a massive scale at construction sites to make sure the sand is totally free of pebbles and stones. Okay, but what about getting solids out of liquids? For things like dust or soil mixed in with rice, we turn to a two-part method: sedimentation and decantation. They're a team. The process just makes sense, right? First, you add water and let gravity do all the work. The heavier stuff sinks and settles at the bottom. That's sedimentation. Then you just carefully pour the dirty water off the top, and that's decantation. But for those really, really fine particles that just won't settle down, we need a much more precise tool. And that's where filtration comes in. A filter is basically like a super fine sieve that traps all those tiny solid bits and only lets the pure liquid pass right on through. So let's circle back to our tea example. Which method is better? I mean, decanting might help a little, but you're probably still going to get a few soggy leaves in your cup. Filtration, using a tea strainer, is just way more effective. It catches all of them every time. Okay, so we've built a pretty solid toolkit here. But what happens when you run into a really tricky mixture, where just one of these methods isn't going to cut it? Let's take on the classic challenge: trying to separate salt and sand. As our source material points out, trying to handpick this mixture is, it's impossible. Forget about it. The particles are way too small and they look too similar. This is a puzzle that's going to require a few different steps to solve. And the solution is to actually combine our tools. First, we use water as a tool itself. We add it to the mixture, and it dissolves the salt, but it leaves the sand completely untouched. Great! Now we can just filter the sand out. But how do we get the salt back? We use another process: evaporation. We heat the salt water, the water turns into steam, and it leaves the pure, solid salt behind. And hey, if we want the water back too, we can use one last tool, condensation. We just cool that steam, and it turns right back into pure water. Pretty cool, huh?
But here's one final twist in our story. Our friend Pahaley from the source text, she tried this exact method. She mixed a whole bunch of salt with sand, but when she was done, she found she could only get a small part of the salt back. What could have possibly gone wrong?
The problem has to do with something called a saturated solution. See, water can only dissolve a certain amount of salt. Once it hits that limit, it's full. It's saturated. Any extra salt you add after that just stays solid, mixed right in with the sand. Pahaley probably just used way too much salt for the amount of water she had. And this leads us to a really fascinating final question. Is there a way to push past that limit? Can we somehow trick water into dissolving even more salt than it's supposed to be able to handle? And the answer is yes. You just have to heat it. Hot water can dissolve a lot more of something than cold water can. And that brings us to one final thought for you to chew on. If you want to make the absolute sweetest lemonade possible, should you dissolve the sugar in the water before you add the ice or after?